Hey guys, welcome to lesson 2.2.2 day 1. Today we're going to talk about transformations of lines. So basically we've talked about transformations of like every other graph, and now we are down to the most basic one, which is just the straight line. Before we get to that, we're going to do a little bit of review just to make sure that you guys don't forget how to do some of this older stuff, which is solving by factoring and then also solving by cross multiplying. So for this first problem, if we are to solve by factoring, right, the first thing you want to do is to go ahead and factor the quadratic equation with our usual box and diamond method. Okay, so remember the top left is going to be your first term, bottom right is going to be your third term. All right, and then we go to the diamond. Now for the diamond, the top is going to be the first term times the third term. So we got a negative 40x squared here because negative 40 times x squared. And then for the bottom, we get negative 6x. It's that middle term. Okay, now we have to play the game. What two numbers multiply, that's what that dot is, the multiplication sign, multiply to make negative 40 and add to make negative 6. Okay, you can play around with the options, but eventually you'll see that 10 and 4 does give us that 40 we're looking for, but now we have to play around with the signs, right? Because 10 plus 4 is not going to be negative 6. 10 times 4 is not going to be negative 40. So if we did negative 10 and positive 4, we know that negative 10 times 4 is negative 40, so it works. Negative 10 plus 4 is indeed negative 6, so that works as well. Once we know that it works for both conditions, we can go ahead and fill in the rest of our boxes with those values. Okay, now we can go ahead and fill out the outside of the box. So we know that x and x go here, and down here we have a negative 10 because x times what gets us negative 10x? Well, that would be negative 10. By same concept, x times what gets us 4x? That's going to be a 4. So once we get to this point, right, we know that from factoring, we would just rewrite our equation like this and call it a day. But because it's equal to 0 and our goal is to solve it, you have to go that extra step of actually solving for x. And it's just a basic zero product property step after that, but sometimes people tend to forget it. Right here, if we solved this part, it would get us an answer of x equals negative 4. From subtracting 4 on both sides, and then here we'd get x equals 10 from adding 10 to both sides. All right, for the next one, this is a cross multiplication problem. So this is where you take your diagonals. Okay, I'll do one in purple and one in green here, and you multiply, hence the name cross multiplication, right? On one diagonal, we have 4 times 3x plus 5, so we'll set that up, 4 times 3x plus 5, and then equals the other diagonal, multiply those pieces, 3 times 2x minus 3. Once we get that portion done, all we have to do is to go ahead and distribute, combine like terms, and now we're on a journey to solve for x, right? So I can go ahead and distribute whatever is on both sides of the equal sign. So 4 times 3x is 12x, 4 times 5 is 20. And on this side, we have 3 times 2x is 6x, 3 times negative 3 is negative 9. Okay, now that we're here, this is just, old stuff. We want to move things around, get the x's together. It would be the most beneficial to subtract the 6x from both sides. And there are multiple ways you could go about this, but personally this is the step I would take. Here it cancels. Here you end up with a positive 6x. 12 minus 6 is 6. And then the 20 just stays how it is. On this side we have a negative 9. Okay, now we need to get that x term by itself, so let's go ahead and move this 20 to the other side. And so on the left, we end up with 6x. On the right, negative 9 minus 20, that's going to give us a negative 29. So if we go ahead and do our last step, which is divide both sides by 6, to get that x finally by itself, we end up with a final answer of negative 29 over 6, which is going to be, I mean, you can keep it like that if you'd like, or you could say it's negative 4.83. All right. So that's all for the review materials for today. For the new stuff, we have the parent function of the line, and then that is what we're going to use to do our transformations. It's going to be very similar to what we've been doing with the other parent functions. So here is just a picture of what the parent function of a line looks like. As you can see, the locator point here is at 0, 0, and the parent function itself is y equals x. And the graphing form for a line is right over here. It looks just like the other ones we've been working with. It's just that this one doesn't have an exponent around the, or next to the parentheses, right? Or it doesn't have square roots, that kind of thing. So let's go ahead and look at what all those pieces do, because it's slightly different from what we've been used to in some ways. So if we look at this a value, let's go ahead and go to Desmos and experiment. All right. If we change this a value, let's say it's a 2, we notice that it kind of gets steeper, right? The bigger it gets steeper. And the smaller it gets, let's say we do a small number like 0.5, this time it gets less steep, right? So it actually controls the steepness. And if you actually look closely, like let's say we made our a value 2 over 3, and we look at this, we see that at 0, if we went a rise of 2 and a run of 3, we end up at our next point. So really, this a value not only controls the steepness, but it's also the slope of our line. So it's the slope. It controls the steepness. All right. So now let's go ahead and play around with the h value. This is going to be something that's more familiar. So let's go back to that being a regular 1. Now here our h goes inside of the house, as I like to call it. If we made it a 2, notice how a minus 2 in the parentheses moved us to the right by 2. Minus 3 moves us to the right 3. Minus 6, you'll see that we moved all the way to the right 6. Similarly, if we did a plus, it would move us to the left. Notice how from 0, it now got to negative 3 because of this plus 3. All right, so just like before, h is responsible for left and right movement. All right, and just like you guys are used to, let's change all this back, k moves us up and down, right? If we do a plus 2, notice how now it moved up 2. If we do a minus 2, notice how now it moved us down 2. So, up, down, shift. This is still our vertical, oops. Up, down, shift. This is still our vertical. This is still our horizontal. Okay, so that stays the same from what we already know. All right, here are two problems dealing with the equation of a line and kind of playing around within that realm. So using graphing form, we're going to write an equation of a line with this slope that passes through 3, 9. So we know that the slope of 4/5, that means our a is going to be 4/5 because we said that a value is the slope. And this is what we're going to use as our h and k values, right? If our locator point moved to 3, 9, that means that we have an h value of negative 3 and a k value of 9. So when we write our equation following this format, we know that it is y equals, a value comes first, so 4/5, and then x and then h in there next, so x minus 3, and then k on the end, our k is 9, so plus 9. It's kind of ugly. All right, and that is how you would do the graph of a line. All right, so one more here. This one's a little bit different. It requires a slope formula, which is a good old Algebra 1 concept. First thing we want to do is find the slope, and that slope formula is actually this. It might look familiar to many of you. All right, y2 minus y1 over x2 minus x1. This is actually also commonly known as rise over run. I'm sure a lot of you guys know it like that. And basically it's just saying find the difference of the y's, find the difference of the x's. So we know that we can call this our x1, y1 point, and this can be our x2, y2 point. All right, so we have y2 is -2, y1 is 5, x2 is 8, x1 is -1. Okay, so let's just go ahead and calculate this. -2 minus 5 is -7. 8 minus -1 is +9. So this is our A value. Which is the slope. All right. So now that we have that, we can actually go ahead and write our equation now. So the thing about this is that we can actually choose either of these points to go off of for our h and k information. So if we did it for this one, we can make the line that is -7 over 9. And then for our h and k, we would have x plus 1, since it's a -1, and then plus 5, since that k is a 5. Or if we use the other one, let's make that another color. Let's do this one. It's a fun color. For this guy over here, we can say y equals, again, the slope is the same regardless of how we do this, so still going to be 7 over 9. But then this time we get our h and k from this point, so that +8 means we're going to have a -8 in here, and then that -2 means we're going to have a -2 out here. So both of these are actually valid equations that belong to the same exact line. That's a really cool thing about linear equations, right? Both of these equations, when you graph them, they will give you the same line. All right, and that is all for today.